this is Damon Tordini, Product Manager with Hawkridge Systems, and I'm here to talk about the free-flowing liquids enhancement for SOLIDWORKS Flow Simulation 2018. SOLIDWORKS Flow Simulation is the built-in computational fluid dynamics tool for SOLIDWORKS, and one of the most popular uses of this tool is for design engineers to test out the performance of a wide variety of industrial equipment, things like tanks, pipes, valves, manifolds. In particular, the behavior of certain liquids flowing through that system to figure out what the flow rates or required pumps or pressure drop would be through different components of the system. And among many of the normal results like pressure or velocity that you would expect from such a simulation, it's also been popular to simulate mixing of different kinds of fluids, for example, water and another chemical additive to see if there's the appropriate concentration. But a big limitation to this kind of simulation in the past has always been that you could only mix fluids of the same phase. That means liquids with liquids or gases with gases. And there was no way to simulate the flow of a liquid when the surface of that liquid might not be contained by the geometry. So for example, liquid water flowing down the side of a chute or out a pipe or sloshing around in a tank. All that has changed with the new free surface functionality that's been added to SOLIDWORKS 2018. The key to this functionality is to enable the appropriate checkbox when you're setting up your project in SOLIDWORKS Flow Simulation. If we go to create a new project using the wizard, for example, free surface, at the analysis type screen, you'll see a new checkbox at the bottom of the list in SOLIDWORKS 2018 called free surface, which we can check and see a warning message that says that we're going to require to turn on the time-dependent option when we enable this. And that's because in a free surface simulation, the development of the flow field, particularly when and where the surface of the liquid starts to form, where it mixes with the air, is really important to capture. So any time-dependent effects need to be included in the simulation, which means that checkbox will be turned on automatically. And if you haven't done a time-dependent simulation before in Flow, all you need to do is to put the total analysis time you want to run something for example, 30 seconds, and then how often you might want to save the results, for example, every 1 second. Now, when you set up the simulation in this way, the other key, of course, is selecting the fluids, and we've always been able to add things like water or air from the flow simulation database, but now you'll see that we have the new fluid type of immiscible mixture as an option, meaning that the air and water will be in the same volume at the same time, and the boundary between the two will be calculated by the solver. This also means when we're going to set up the initial conditions and also our boundary conditions, we need to select which of those two fluids is going to be present. In this case, I want to simulate an empty tank that's getting filled up with water. So for my initial fluid, I'm going to select air. Now when I go to define my boundary conditions, which is a normal part of the process in flow simulation, I'm going to have that extra drop-down menu in here as well. So for example, when I put on this volume flow rate of 500 gallons per minute at the inlet, I'm also going to need to go down to the substance concentrations menu, drop down and click water, and that will make sure that only water is coming in from the inlet here, which will of course gradually fill up the tank over time. And then similarly at any other boundary conditions like my outlet vent over here, I'll select the opposite. So that water is going to fill up the tank and push the air out of the environment pressure condition that I've got in the front. Now, when you want to run these simulations, as with any time-dependent analysis, we're going to get results at different points in time. You saw me select in the wizard that I want to save my results every 1 second. However, if you go to the calculation control options, we have another option that you'll most likely want to enable in these types of simulations. If you go to the Saving tab, you'll see that at the bottom there's something called Selected Parameters for the Transient Explorer. And what this will do is save select results, for example, only pressure or only velocity or a few other ones that you might select, and it'll do that for every single iteration rather than at a time interval. What that means for you is getting much smoother and more complete animations of any kind of transient effect, including a filling simulation like this. Also, in certain cases, you may want to enable the nested iterations option under the solving tab, which is a great way of speeding up the calculation time for any transient problem like this. You can see here I've enabled it, and my time step is still automatic, but I could also have manually put in the time step and still gotten accurate results thanks to the nested iterations option. So when I run my simulation here, which in this case took about 5 minutes, I can load up my results, and the best way usually to view such results is with a cut plot. So I can show my cut plot here, and you'll see that I've got my volume fraction of water parameter selected. So this is simply showing the percentage from 0 to 100% of water that's present within each cell of my mesh. And one of the color options that you could choose for the plot, of course, is just white to blue, which looks really nice for water. Now, by default, the results I'm seeing here on the screen are simply those at the end of my analysis, in this case 30 seconds. But if I want to see the transient animation of the filling, I could right-click on Results and enable that Transient Explorer that I mentioned earlier. This will give me a nice pop-up animation time bar, which I can play and see every iteration that was calculated of that filling process, seeing both the tank fill up and, of course, the water falling to the bottom due to the effects of gravity, as well as some of the vapor and mist that splashes around elsewhere in the tank. Now, of course, the real benefit of using flow simulation is the ability to compare changes of your design and the effects that that might have. And so, for example, here I've got another configuration I've made where I lower the inlet just to see what that might do to the pressure required to pump the water in and fill up the tank. And of course, I've got another animation here that I could view. And among other things, I could see my cut plot again like I had before and use the compare tool to look at both the cut plot and my goal results that I had specified earlier. So in this case, I'll check the box to look at both configurations, look at the cut plot and the goal plot side by side, and I can see, first of all, that the filling animation and surface of the liquid looks different, and more importantly, the pressure required and the filling time over the course of the simulation has changed. So immediately I get to figure out how much more pressure or more power I would need out of my pump to fill up my tank, and whether that would affect the overall filling time and performance. So just another capability to expand the realm of problems you can simulate in SOLIDWORKS Flow Simulation 2018. Thanks for watching. Please stay tuned to the YouTube channel and blog for all of the new enhancements in SOLIDWORKS 2018.